Hello everyone. Today in this video we'll be covering the order of precedence. Now basically where this arises from is the fact that when we covered naming of several different organic classifications of functional groups, we did cover them individually. We did not cover the fact, okay, what if many of the organic functional groups are together in one single compound? How would the naming take place then? In front of you in a list form are many of the organic compounds or the classification of compounds of which the naming we've covered in the previous videos. Now in this video we'll be studying how we would name compounds that have several of these classifications in one single compound. Now this order of precedence is in a decreasing order, meaning that carboxylic acids are on number 1, esters are on number 2, and amides are on number 3, nitriles on 4, aldehydes on 5, ketones on 6, and so on, alkanes on 11, right? So you need to keep these in mind. Why are these in decreasing order? It means that carboxylic acid holds precedence over all the other classifications. Similarly, esters holds precedence on all the classifications below it. So you need to keep these in mind, and when we do these examples on the next slide, you will get a handle on how exactly we inculcate this order of precedence series. So you need to remember this order of precedence series because it will not be given to you in the examination. Why and how exactly this order of precedence series was made is not in your syllabus, but just for your knowledge, I will let you know that it has been made due to the strength of how much a compound can be oxidized, and keeping in mind that carboxylic acids cannot be oxidized to another compound or another classification. Therefore, it is the most preferable compound. It is at the highest of the order of precedence, right? Now moving on. Now, you need to keep in mind that when alcohols are substituents, what am I saying? I'm saying that when alcohols are substituents, they are called hydroxy. Now, let's look at that. Okay, let's keep that in mind. So, the first example that I have, you will notice that it has an alcohol functional group, which is the hydroxyl group, and it has a carboxylic acid functional group. Now, how exactly would we name this compound? It has two functional groups in it. Now, we know that carboxylic acids hold precedence over alcohols. So, you need to keep in mind that the alcohols are now treated as a substituent and they will be called as hydroxy. So, let's see how many carbons are in this compound. 1, 2, 3, 4. Now the functional group that has precedence is the carboxylic acid functional group, which is why we are numbering from the right hand side so that the carboxylic acid functional group gets the smallest number. Remember that. So now let's name this compound and make sense of it. 3 hydroxy butanoic acid. Now, how exactly did we name this? Let's look at it. The 3-hydroxy is there because on the third carbon atom we have a hydroxyl group, which is the alcohol functional group. Butanoic acid is there because there are 4 carbons in the longest carbon chain, therefore it is a 4-carbon carboxylic acid. Now let's look at the second example. Again, it has an alcohol functional group and it has an aldehyde functional group. C double bond OH is an aldehyde functional group. Keep that in mind. And remember the fact from the order of precedence series. If you want to, I will scroll back. Aldehydes hold precedence over alcohols, right? So this naming will be made according to aldehydes, and the alcohols are a substituent yet again. So let's number from the right hand side so aldehydes get the precedence. Now it is a 6-carbon aldehyde. So on the 6th carbon we have the alcohol substituent. So let's name this. So the name of this compound is 6-hydroxyhexanal. Why 6-hydroxy? Because the sixth carbon of the carbon chain has the alcohol group next to it, so therefore it is as a substituent and it has the name hydroxy. Hexanal, because it is a 6-carbon aldehyde. Now the third example, we have a carbon double bond carbon which shows an alkene group, and we have an aldehyde group. So now let's look back at the order of precedence series. Aldehydes hold precedence over alkenes, therefore the numbering should be done from the right hand side. 1, 2, 3. So now let's look at the naming. 2 propenal. Okay, now let's study this a little bit because you have to focus on this one. 2 is there because the second carbon atom has the double bond carbon-carbon. Prop is there because there are 3 carbons. This E is there because of the alkene. Keep this in mind. Normally, if we had an aldehyde, it would be called propanal. There would be an A, right? But now there is an E. So keep in mind that this E is because of the alkene, okay? Then we have nal at the end, which is just significant of the aldehyde present in it, right? And now the last one is just a normal aldehyde. It is a 3-carbon aldehyde called propanal. So focus on the E and the A's, right? Usually you would write A, but if there is an alkene and an aldehyde together, it would be enal, right? So now let's look at the next example. What if aldehydes and ketones are substituents? If aldehydes and ketones are substituents, they would have the name oxo in them, right? So now let's look at some examples. This compound has an aldehyde group and it has a carboxylic acid group. Remember the fact that carboxylic acids hold precedence over everything else. So let's number this compound. It is a 5-carbon compound. So generally we would write it down as 5-oxopentanoic acid. So why is the 5-oxo there? 5-oxo is there because the 5th carbon atom has the aldehyde group attached to it. Since the aldehyde group is a substituent, it is treated as a substituent because the carboxylic acid holds precedence. It is going to be called oxo, and pentanoic acid is there because it is a 5-carbon carboxylic acid. Now let's look at the next example. Now this one is a ketone group. It is a ketone group because we have an alkyl group and a double bond O carbon. And there is a carboxylic acid group. Simply put, carboxylic acid hold precedence over everything else, so we will number from the right hand side. It is a 5-carbon carbon chain. Therefore, let's see now how to name it. It would be called 4-oxopentanoic acid. Why 4-oxo? 4-oxo is there because the 4th carbon atom from the carbon chain has the alkyl group and the basically the ketone group attached to it. So oxo is going to be used when aldehydes or ketones, any of them, if they are used as substituents. Pentanoic acid is there as it is going to be a 5-carbon carboxylic acid. Now let's look at the third example. Now in the third example, we have an aldehyde group and a ketone group. Now when we have an aldehyde and a ketone group, let's look back at what holds precedence. Aldehydes hold precedence over ketones. So keep in mind that we will be starting from the left hand side. 1, 2, 3, 4 and 5, right? Now keeping this in mind, let us look at Okay, so aldehydes hold precedence over ketones. So we will start from the left hand side, and this is what we get. Now let's name this 4-oxopentanal. Why is it 4-oxo? It is 4-oxo because the fourth carbon has the ketone group attached to it, therefore it's a substituent, and therefore it will be oxo. Pentanal because it is a 5-carbon aldehyde, right? Now the next example, there is an aldehyde, an alcohol, and a carboxylic acid group. Now, how exactly do we name this? Let's keep in mind some things by looking back at the order of precedence. Carboxylic acids hold precedence over aldehydes, which hold precedence over alcohols. So, alcohols and aldehydes will be treated as substituents in this question. So, let's start numbering from the right hand side. This is what we get. So now let's look at the naming first, and then let's see why it is the name. 3-hydroxy 4-oxo butanoic acid. Now why 3-hydroxy? You can clearly see that the third carbon has the alcohol group attached to it, therefore it's a substituent, therefore 3-hydroxy. 4-oxo because the fourth carbon of the chain has the aldehyde group attached to it, and it is a substituent, therefore 4-oxo. Butanoic acid because it is a 4-carbon carboxylic acid, simply put. Now moving on to the last two examples of this video. Now over here we can clearly see that we have a ketone group and we have an ester linkage. So it is an ester and a ketone. So let's see in the order of precedence what holds precedence. The esters hold precedence over ketones. So it must be named according to esters. So let's count from the left hand side. Now the first carbon is this one. 1, 2, 3, 4, 5, 6. Right? So now let's see. The name would be we will start from here actually because that is where the ester linkage is. And this methyl group is going to be a substituent, right? So now let's look at this. The name is methyl 3-oxopentanoate. Now, if you keep in mind, this is how we name esters, right? This is the alcohol portion of it, however esters are formed, and then the left hand side of the carbon double bond O, carbon single bond O would be the carboxylic acid side. So we should keep in mind that the methyl will be because of the alcohol part, and the 3-oxo is there because of the ketone substituent on the third carbon atom, and the pentanoate is there because of the carbon chain being 5 carbons long. So keep that in mind, right? Now let's look at the next example. We have an aldehyde, we have a ketone, and we have a carboxylic acid. Now carboxylic acids hold precedence over ketones and aldehydes both. So we'll be counting from the right hand side. So we would get 3,5-dioxopentanoic acid. Why 3,5-dioxo? 3,5-dioxo because on the third and the fifth carbon atoms we have a ketone and an aldehyde group respectively. They both are substituents, therefore we have dioxo because oxo would come 2 times. Pentanoic acid because there are 5 carbon atoms in the longest carbon chain, so therefore a 5-carbon carboxylic acid. And that is it for naming and for this video. Thank you.